Okay, so we'll have a little look at long division. This is something that people get a little bit stuck on. So polynomial long division. I find the best way to do this is to go through an example quite rigorously. And there's no real equation way of just remembering it and subbing it in, you just have to learn the method. So we'll take an example. So let's say we have the equation x cubed minus 2x squared minus 4. And we want to divide it by x minus 3. So essentially trying to find if 3 were a factor. When you're doing the long division, you notate it like this. So the bus shelter method, as you probably know it from by primary school. And if you have an x term in it, you'll want to put a coefficient of 0 in front of it because it keeps all the separate terms spaced out nicely. And if you had the x term here missing, then you'd miss a whole point and it can get a bit confusing. So what you want to do is you want to get rid of each term individually. So you want to times this x minus 3 by something that will get rid of the x cubed. So by doing that, you times it by x squared. And that means when you times it, you get x cubed minus 3x squared. So you times this whole thing by that. And then you want to subtract this off of the top equation, like so. And by subtracting it off of the top equation, you're then left with minus 2x squared plus 3x squared, and that gets this thing. And then you bring everything else down and you repeat, but this time you're wanting to get rid of x squared instead of x cubed. So you times the whole thing, the x minus 3, by x, like so. And then you've got x squared minus 3x, and this is why you have the 0x here, because if you didn't have the 0x here, then you wouldn't really know what to do with this minus 3x. It would kind of get a bit confused with the 4. So then we subtract that off, and we're left with 3x minus 4. So you want to get rid of the 3x, so you do x minus 3 times 3, and then when you subtract that, you'll get rid of the 3x. So we multiply this whole thing by 3, and then we subtract it all. And then we've got 5 left at the end. And because we've got 5 left at the end, it doesn't work with the x. You can't times it by anything else to get the 5. So what you want to do is you want to leave it as that, and this 5 is treated as a remainder. So if you divide 20 by 7, you get 14 remainder 6. In this case, you've divided x cubed minus 2x squared minus 4 by x minus 3, and you've got a remainder of 5 left at the end. So you take it up, and once we've divided this by here, we've got the remainder 5, and we've got this thing as what the kind of division is. So with the previous thing that I mentioned, 20 divided by 7, that would be 2 remainder 6. So this would be x squared plus x plus 3 remainder 5. So that's the answer to the long division. And this is the way that you notate it. So you say x cubed minus 2x squared plus 0x minus 4 equals x minus 3 times x squared plus x plus 3 plus 5. So if it was a perfect division, then you wouldn't have a remainder left at the end. So perfect division would be 21 divided by 7, you'd have 3, you wouldn't have a remainder left. But what this means is if you multiply this side out, you'll get this exact thing left at the end. You can check that quickly. You've got the x cubed plus x squared plus 3x minus 3x squared minus 3x minus 9 plus 5, that gives you the minus 4. The x terms cancel out, and then you've got the minus 2x squared here and the x cubed that you just get from the x times the x squared. So it's important to remember the form it's left at in the end and what they're called. So the dividend is the thing that you're having being divided. The quotient is the thing that you're dividing by. The divisor is the answer that you get at the end. So these bits, and the remainder is the plus 5. So that's the end of this video. Remember to like and subscribe, ask any questions if there's something you don't understand, or if you want another example. If there's anything you don't see in my videos on my channel, then just let me know and I'll try and go through them.